Okay, we're live. Welcome, everyone. This is the Round versus Flat Earth Summit, and we're going to be applying the scientific method. Let's go to video, Suresh. So we have a set of panelists here, and I'll give you the background, and then we're going to jump right into this. There's a very, very important question about, it's not about flat or globe Earth, and I'll explain how I got involved in this. Let me just bring up the agenda here. We put together an agenda for this morning and bring it up. Okay. Okay, so let me just go through the agenda here for today. We have a lot to cover, but the official name of this we did was Round versus Flat Earth Summit, applying the scientific method. We have 3 people on the Round Earth team, and we're supposed to have 3 people on the Flat Earth team. And what I want to do is I want to walk through the following agenda. We're going to do welcome, and we're going to give the history and the mission of the summit. We're going to introduce the panelists, and then we're going to give the format of the summit. And then we're going to, for the audience out there, we're going to review the scientific method. In fact, I'll give a simple example of applying the scientific method. Points 1 through 6 should occur in no more than 15 to 20 minutes. And then we're going to jump into the meat of this, where we're going to review proposals for exploring the question of round versus flat Earth using the scientific method. And then we're going to review each of those proposals on one specific, on a bunch of criteria that we agreed to in the pre-meetings. We've held 2 pre-meetings. Can you actually do these experiments? Cost? Is it viable? And can, ideally, we want to make sure any citizen can do it, any one of you listening. We don't want to make these experiments so esoteric, so hard to execute, that it becomes only reserved for a few set of people. And then one of the things we agreed to is the skills of mathematics seem to vary. On the Round Earth side, when we go to the introductions, you'll see we have a number of people who are actually engineers, have degrees in engineering, advanced degrees. And it seems like on the Flat Earth side, there's a very sparse background in mathematics. So therefore, in order to be fair, what we did was we decided after today, we're going to give people a week to go do their mathematical formulations. So if they want to go consult experts, ChatGPT, Gemini, go to universities, open book, like an open book exam. We want to do that because we don't want anyone moaning and groaning saying, well, I didn't know math or I didn't know this. Everyone can go consult as many experts. So we're going to do a follow-up next week. So first of all, I want to welcome everyone. What you notice the way we've done this summit is we have the audience here, the 6, well, one of them is missing. It's very unfortunate because we spent a lot of time organizing this, multiple emails my assistant set out, and it seems like some people are just sloppy. And it perturbs me because we spend so much effort organizing this. But nonetheless, we're going to move forward, even with the absence of one individual. Hopefully he'll show up. But I want to welcome everyone because this question of flat Earth has been put out in the audience. And I want to review how I got involved in this. I do various interviews, and a guy by the name of Flat Dave or something, had me on an interview. And he said, you know, the Earth is flat. And you guys can go see it, it's all public. And I said, whoa, stop. I said, can you describe the scientific method? And again, you guys can go see this. And I was horrified that he didn't even know what the scientific method was. And this guy's promoting, he makes quite a bit of, he has his own website, he promotes this, and you guys can go look at it. He didn't even understand the scientific method. So we have a larger problem, particularly in the United States, and for that matter, different parts of the world, where young people, perhaps it's the STEM education, public school education, or private school, people aren't learning what the scientific method is. According to the latest statistics, less than 5% of people actually know what the scientific method is, even have mastery of it. And we're going to walk through that. And I spoke to a bunch of my friends who are educators who spend a lot of time teaching. In fact, I spoke to one of my high school teachers who's in his almost 80s. And I explained this to him. So my mission in doing this was to give a broad reset, hopefully as people see this video and the commitment of various people who come, to understand what is the scientific method and to make people accountable to the hard work it takes to apply the scientific method. We have grifters who seem like they can say whatever the fuck they want without any accountability to evidence. And the reason this has occurred is the educational system, and B, what is evidence? By the end of this summit, or through the summit, you will understand that evidence is reproducible predictions. Those two words are very powerful words, and I would again say probably less than 5% of the public actually understands what evidence is. Evidence in science is reproducible predictions. And we're going to, as we've had our pre-meetings, we're going to make sure everyone adheres to the scientific method. Otherwise, anyone can say whatever the fuck they want. And that's not science. Okay? So again, my motivation in this was not about the question of flat or round, but as a PhD, as a guy who spent a lot of time educating people, spent a lot of grueling hours solving problems, it became evident there's a whole set of people, particularly on the internet, quote unquote influencers, who have no regard for science, who can talk a lot. They can talk very beautifully. And people think they're saying something, but when you take away the layers, they're saying nothing. And this is not only among the grifter class, but also in universities. And I'll show you an example of that. So we live in a very dangerous time because anyone with a microphone and a camera can say what they want, but they don't have to back it up. But today's summit, the way it's organized is you're going to have to back up what the fuck you say. And I'm using some of these annoying words because the level of conversation needs to be seriously elevated. And I think what we're doing today is a public service. This summit is brought to you by the International Center for Integrative Systems, all volunteer run. There's no one grifting here monetizing this. This video is not being monetized. We're doing this. A number of people here have families. They've taken time out of their weekends to do this. So I appreciate all of that. So that's the background. We don't want to let people get away with saying stuff that they cannot back up. They got to be able to back it up. And we want to create a consciousness that people demand that of these grifters, as well as their politicians and public officials. And so I want to thank everyone here for participating. We're supposed to have 3 on the flat earth side, 3 on the round earth side. 1 person's missing on the flat earth. And then we have other people we invited to, if they just want to be in the Zoom audience, and then we're also streaming it. So let's go back to the agenda here. Let's introduce the panelists. I have a picture of all of them here. Let's start right here. Let's introduce, we'll do the round earth side first. If the people can just say your name and a quick background. Let's start with Dr. Dinakar.
Good morning, everyone. My name is Prabhakar Dinakar. I am a biomedical engineer, trained as a chemical engineer, but I did my postdoctoral studies in biomedical engineering, and my interest in my interest in this particular topic is solely for the fact that we need more scientific method in answering any questions especially the questions that such as whether the fundamental questions such as whether the Earth is flat or round, and these need to be nipped in the bud in a sense that these need to be taught in a in a school level. It shouldn't take a summit like this to have a clarity on such a fundamental questions. So that's my interest.
Thank you, Dr.
Thank
Dianker.
you.
Then we have Michael. Mike, you can introduce yourself. I know some people don't, for anonymity, you didn't want your last names. Believe it or not, some people like Mike have actually gotten death threats by people on the flat earth side. And this is of serious concern. And those people were not invited because they seem to be nuts. And so this is a serious issue. It seems like if you go against some narrative that people are monetizing on making money, you actually get death threats. So Mike has shared that with me. It's very unfortunate, but we did not include those people here. Go ahead, Mike.
Yeah, thank you. At university, I studied electrical engineering and computer science. I've written software for my professional career. And for the last 7.5 years, I've been engaging in this flat earth and globe earth discourse, and have a channel, MC Tune Live, and another channel, Conspiracy Tunes, where I look at these two things. I debate flat earthers often on my live channel, and anybody's welcome to come watch if they like to see a 2+ hour interchange between myself and some people that don't generally understand science.
All right, Mike, thank you. And then we have Dan here. Dan, go ahead. I think Dan's good.
Yeah, hi. My name is Dan. I started off in signals intelligence in the Navy, doing radio and satellite networks and during combat deployments. Been a telecommunications engineer with radio and fiber optics for the better part of 25 years now. Originally, I started in this primarily as a byproduct of my teenage daughter having TikTok and seeing some of the videos that were on there about flat Earth and things like that. I've been doing this roughly about 2 years now, started on X, and have now migrated over to YouTube, and can be found on Unfornicated on YouTube, where we do some science communications about things in my background to kind of teach people about things like radio, fiber optics, and the EM spectrum, and like speed of light, and then also we go into some of the more obscure history things that aren't taught in schools to kind of shine a light on some of those things that that matter.
All right, thanks, Sam. All right, let's go to our team on the flat earth side. Let's begin with Kevin Samuel. Kevin, kindly go ahead, if you can give people your background.
Mute me. Now I'm unmuted. You hear me? Yes, Kevin.
Yes, we can hear you. Yep.
Kevin Samuel Bow is my YouTube channel. I studied media economics. It's I did online courses after that in alternative money systems. I criticized the nowadays money system a lot. So I think I have something in common with you, how things are bad in economy. But I peeked into other stuff, and I also saw too far in a vacation. I could see an island I couldn't see, and I got interested. I researched that. I digged into theories a lot, and I did a lot of some experiments I did myself. I did experiments with a fishing line, stuff like that, and I like to present something today, which I think can be decisive and includes the scientific method. And I hope we keep calm, everyone, and keep it to science.
Great. And Kevin, you're out of Austria, right? Just to let
yes.
3 people are in the United States. Kevin's overseas, so we want to thank Kevin. I don't know what time it's there, Kevin, but it must.
Oh, it's okay. Today is okay. The pre-meetings were late. Today it's 5:30 p.m.
Okay, great. Let's go to Ryan Shea. Ryan's here in the United States. Go ahead, Ryan.
Yeah, hi. Can you guys hear me? Yeah. My name is Ryan Shea. I am from Dallas, Texas, currently in Houston, driving right now. I've got an undergraduate degree in marketing and management, master's degree in leadership. Most of my professional career was in coaching college soccer, then have now been in real estate as a realtor and investor, entrepreneur. And it was probably about 5 years ago, someone, when I was in a tall building, said, "Hey, we can see pretty far here, can't we?" And brought up the flat earth. So I was like, I had no idea. I mean, what I was taught as a kid was we're on a globe spinning around 1,000 miles per hour, hurtling off into space. And there's this solar system and all this stuff. And it just took it for what it was. And I started doing my own research, doing my own testing. Have done a light test across the lake that was around 7 miles. And, I've done many other independent research on this subject. And when Dr. Shiva had brought up using the scientific method, I thought, oh, this is great. This is good. This is exactly what we want to do. We want to have facts and we want to know truth. And another part, I think just quickly, is that I'm also a part of the Truth, Freedom, Health movement. So I would say what we do here is it's all about facts. I don't care about anything other than what the truth is. And when our freedoms and health is actually absolutely diabolical right now in this world and country, it's not okay. So that's what attracted me to Dr. Shiva in this bottoms up movement that I'm also a part of. And then, so with this flat earth, I wanted to get involved, flat earth, round earth debate, and do what I can to help. So that's it. Thanks.
Okay. And the third person we're supposed to have is, I think his handle is Globe Slayer, right? Bobby. But he was supposed to be here and he's not. So before I started, I was frankly annoyed because we spent a lot of time communicating to people, getting people out here. And I wish people would follow through on their word. But anyway, we're going to start. Let me go back. So thanks everyone for those introductions. I think people understand the mission here. It's to really apply the scientific method. And across what I've seen, from this past year, when you look at this question, it's been unfortunate that people haven't applied the scientific method. So the part of what we wanted to do in the next 5-6 minutes, I did this in a long video, but to the audience out there on social media, plus the audience here, what is the scientific method? We wanted to review it. We've had pre-meetings on it. We've gone over the terminology. Everyone's on board, but we just wanted to level set for everyone else, because that framework is what's going to be used for anything we do. And that framework is what's going to be imposed on anyone, the panelists who are participating on both sides. Is that clear? That's the ground rules. So let's review what is the scientific method. Let me go back to the slides here. So in the scientific method, you begin with an observation. Okay, let's say you have a car. There's some force put on the car, F. It's of some mass, and then it accelerates. Okay, so you see this phenomenon. You could be sitting on a park bench and someone's pushing a car. That's a force. The car is of some mass and it starts accelerating, okay? So the scientific method begins with an observation. You see an apple, Newton saw an apple fall supposedly from the tree, and he wants to understand that, okay? You may see the clouds move. You want to understand that. You see the world heating up or cooling. You make these observations and you want to understand that. So the scientific method begins with an observation, okay? Begins with an observation. So that observation typically leads to some question. Okay, so in this case, if you see a force impinging on a car of mass m, accelerating, you may make a question, and that is denoted as a hypothesis. So, and this is what's important to understand, is the hypothesis is always expressed as a mathematical equation, which means you need to know some math, okay? And if you don't know math, you got to go get someone who does know math to help you. And in this process here, we're allowing people to go get experts. That's why in developing the hypothesis, we're going to give people a week. But nonetheless, you can look at this phenomenon and you can say, oh, there's a force, the car is of mass m, and it accelerates. And you may say, I believe that the relationship between the force and the mass is related by this equation, force equals mass times acceleration squared. Okay, so the force to move that mass m has to be ma squared. That's a hypothesis based on your observation. It could be wrong or it could be right. Okay, so if you're a round earther, you're going to come up with some observation. Could be, you know, an airplane, how it moves. It could be, I think Ryan said a fishing line. It could be the sun's motion. There's many observations, but you use that observation and based on your assumptions, you come up with a mathematical equation. Obviously, technically, a mathematical equation will vary if the Earth is round or if the Earth is flat. And I'm sort of foreshadowing some of this, but nonetheless, you do an observation and you come up with a hypothesis. In this case, someone is saying that force is equal to mass times acceleration squared. Now, if that is true, the evidence will point to that based on what m and a you plug in, you're going to get different forces every time you plug in that m and a, particular m and a. That's called evidence. That's why we say evidence equals reproducible predictions. Okay, so this next thing you would do is you would do some experiment. Okay, you're going to have to design the experiment, and experiments are difficult. You have to have the right methodology. You have to understand the errors. It's not trivial. It's a lot of hard work. And the next thing you do is you gather data and you organize that data. So you would do an experiment. Here we have three variables, F, M, and A, and you would do experiments and you organize. I just did a little table here. Column 1 is F, column 2 is M, and the last column is A, acceleration, okay? So you would organize, it's actually A squared. Sorry about that. Let me, I want to, actually this is right. Yeah, it's correct. Okay, so you would organize the data like this, and these are the results you get from your experiment, okay? And then you would see what this reveals. And you'd find out that the results are force is actually equal to MA. There's no squaring based on this data. Everyone see that? F, in this case, M times A, M times A, M times A. So the hypothesis was that F equals MA squared. In this case, F would have been 1, but in this case, the second case, F would have been 4, and in this case, F would have been 16. Everyone see that? But it isn't. So when you come to this point, you have to deal with the reality that your hypothesis, F equals MA squared, was wrong. In fact, it's F equals MA. Okay? And then you have to deal with the reality that if the results match the hypothesis, which they don't, if they do match, your hypothesis is accepted. If not, it's rejected. This is a scientific method, okay? And we can look at this, but this is what I'm saying is, unfortunately, if you go out on the street, you know, less than 5% of people actually know this. So if less than 5% of people know this, and there's billions of people on social media, and someone's just randomly saying what they want to say, they could bullshit people. So this is the framework why you have an iPhone, okay? Why this works. Because people have to understand Maxwell's equations. They have to understand all sorts of very, very complicated things. And the unsung heroes in a lot of this are engineers. Engineers are the people who actually have to apply science to creating practical things. It's where the rubber meets the road. Engineers are like the boat tech people doing science, okay? So anyway, this is a scientific method. Now, we want to make sure that this is applied in the case. By the way, let me just point out one thing. I was literally walking through my woods here, and I live in a very interesting community of a lot of academics. And obviously I run for Senate. I'm running for Senate again. Some random guy comes up to me and he starts talking about climate change. And he goes, you know, the climate is changing and I don't agree with you. You know, it's obviously the Earth's temperature is increasing based on CO2. And I said, look, evidence is reproducible predictions. And he didn't even know what that meant. And I said, what's your background? He's apparently a humanities guy who happens to run a nonprofit, which gets quite a bit of money promoting the climate change narrative. Okay. Anyway, I said, have you read the IPCC report? Because if evidence is reproducible predictions, then you should get the same answer for how much ice is going to melt, right? Well, if you actually look at the IPCC report, this is what you get. And this is just an example. This is just, there are about 100 different models of ice melting on the Arctic. And each one gives a different answer. So one model says 100% is going to melt, and another model, this one says 0% is going to melt. So when you see something like this, this is garbage in, garbage out. This is not reproducible predictions. Okay? So if anything you learn today at a high level, besides flat Earth, round Earth, evidence is reproducible predictions. So if you ask someone, someone developed a mathematical model for looking at the two fluids, the air and the oceans, and then they computed how much ice is going to melt. Well, none of them are coming with the same answer. Everyone see this? It's like the Baskin-Robbins flavor. Multiple results. And if you bring this up, you're viciously attacked for just pointing this point out. But anyway, this is occurring not only among the grifters on the internet, but at places like MIT. Okay? The only professor who brought this up was Dick Lindzen, and he was vilified by the other 100+ professors. But the point is that we have a serious problem when people aren't following the scientific method. But what you see is, in this case, there's no evidence of ice melting because these models are completely varied, okay? All right, so what we're gonna focus on in today's discussion is, what is the observation each team is proposing, and what is the model and a brief framework on the experiment. These three things we're going to focus on. All right. So again, to be clear, this model always has a set of inputs, variables, and a set of outputs. Okay. So each team here, based on the observation, and we may have multiple, right? I think we've already discussed two. Maybe there's the flat earthers want to do one, and the globe earthers, fine, but it still has to follow this stricture and this framework. But you'll define your inputs and you define your outputs. Okay. So if we want to talk about a fishing line or a laser over thing, or the sun's motion or an airplane, you still have to come up with an equation because we want to follow this process. Okay. This is the structure that both teams have agreed to. Globe earthers will have to do the same thing. So for example, the globe earthers may design their inputs. This is just a function which should predict their outputs. If for any specific input, they get an output all the time, reproducible prediction, then there's evidence that the Earth is a globe. Alternatively, if the flat earthers have their inputs, and they can make whatever assumptions they want. You know, the globe earthers can say, is the sphere an ellipse or is it a perfect round globe? Similarly, the flat earthers can say, is there a dome about this flat disk, or is it whatever they want? It's full freedom. But you have to lay out the assumptions and you have to build the model. Okay? This is not trivial to do this. Therefore, I had originally wanted people to literally get up on a whiteboard and, derive the models. And in the pre-meetings, we realized that people have different mathematical backgrounds. So we're going to give people a week and they can go consult anyone they want. And then November, 15th, we'll come back and people will present their models. All right, so I'm going to stop there. But that's the framework of the scientific method. Okay? We can take, specifically on the scientific method, we do have an audience here. But if anyone has any questions, I don't think we've opened up the chat. Wait until the end of the time. But the bottom line is, this is the framework of the scientific method. All right, let's, I I think the next part we're going to move on agenda-wise is we want to now go to, let me go back to this. We want to go to we reviewed a simple example. We want to now review proposals adhering to the scientific method. So each team is going to propose what the observation they want to use across flat Earth and globe Earth, and then what's the methodology, the experimental methodology that they're going to use. Okay, so we'll start with the globe Earth people proposing theirs, and we'll go to the flat Earth people, and then first we just want you to propose your idea, and then we'll have a Q&A across both. Does that make sense? So we want people to have the opportunity to fully talk about what they want to do. People can take notes, and then we'll go over, and then each team can critique the other team. And hopefully what's going to end as a result of this is a transcript of this, but more importantly, a document, a draft document, a white paper, which will lay out the experiment or experiments. We do have talked about the outcome of this, based on if the methodology is clear, can potentially be published in a decent peer-reviewed scientific journal. This has not been done to date, potentially in the field of science education. And I've started looking at some of those journals, which means all the 6 participants will be authors in that. So who on the Globe Earth team wants to present their proposal? Mike? Oops, you got to unmute, Mike.
All right. Yeah. So a real simple thing, and something that everybody can do, I think, is very important. So, and everybody experiences where the sun is in relation to them every day of the year. So I propose just applying geometry. It's pretty simple. It isn't even a university level thing. It's generally high school, even middle school. Where is the sun in relation to any person on the surface of the earth? So I propose saying, given a date and time and location, where is the sun in relation to where you are, both in a horizontal angle and a vertical angle? And those are typically called azimuth for the horizontal angle, and either zenith or elevation angle, or shortened often to just elevation. The angle is not often said then, but it is an angle. So where in relation to any person is the sun. And so I can put together a model. The rest of us on the panel here can put together a model that will predict for any location and time the position that we expect the sun to be in relation to the globe. So that's I think pretty simple. And then once we have that, anybody on the earth can test that. We don't even need to go travel anywhere. We can even do things like pull up some different webcams in different areas of the world to see if those are matching, or anybody can just contact somebody in a different country and see if they can measure it. And most people's smartphones can measure both of those angles with either for free or for rather cheap. So it's pretty easy to do and very reproducible.
So Mike, I'm just going to reiterate what you said, and then so I'm here. You guys may be able to see. I can look out of my window there, right? I got a big window. Boston's over there. So what you're saying is, if you're looking out in a frame, at any point the sun is across somewhere in the azimuth, which is a horizontal, and it's up at a particular location, right? That's some X1 and Y1, or X2 and Y2. Yeah. So everyone right now, if you look out your window, you're looking in a certain direction, and you yourself are located at a particular point on the earth, globe or flat, and that's known as your longitude and the latitude of where you are. And then you're looking out. And Mike, the proposal here is we're looking at the location of the sun, and the globe earthers will come up with their model of taking in the location of the individual, the date and the time. What is it right now? It's 12:01 here, Saturday, November 8th. That will be the input into your hypothetical model or your hypothesis, and output will be, it'll predict where the sun should be. And then anyone here can go do that, because hopefully this will be published somewhere online, and someone can say, oh, the globe earth model says if I'm in this location, looking in this direction, the sun should be over there. And it is indeed over there, or it's not over there. If it's not over there, the earth is quote unquote not round, right? If you use your formulation. The flat earthers will come up with their own formulation. And if the sun is in that location, then they're right. If both are wrong or both are right, that means it's inconclusive.
Yeah.
Right. All right. Great. Let's go over to the flat earth team and let them propose their proposal. One of the things we talked about is there's 3 sort of features we want. It should be ease of use. Anyone could be able to do it, because we want anyone listening here to be able to do this. So it's not like an elite group of people, only they can do with specialized equipment. The other thing was the cost, which means it's viable. It should be relatively low cost, and it should be ubiquitous, meaning it can be done anywhere. So those were 3 important criteria we discussed in the pre-meeting. So let's go over to the Ryan, Kevin, and Bobby, but who wants to present here?
I will present, yes. You see my screen share?
Yep, go ahead.
Okay, let's make it screen share.
Yeah, you have it. Everyone can see it.
Yeah, I need to make it full screen.
Okay.
So for decades, pilots have relied upon a pair of focused, precisely angled radio frequency emitters. And I suppose the radio frequency plane test with the ILS system for the flat versus globe Earth observation. And the intro is that one RF emitter of that tower is focused direct in line with the horizon. The second is angled upward 6 degrees above that. They do this so that the plane's radar equipment can sense the signal strength of both. The pilot's primary flight display shows the results shown here in the circle of a process which is merely a comparison, constantly made by the aircraft receivers of the strength of those 2 radio frequency signals. When the received signals are the same strength, the primary flight display indicates that the craft is currently on the prescribed path of descent to the runway, typically a negative 3-degree slope, because as you see here, the midpoint between 0 angle from the bottom one and the 6-degree angle from the top one is 3 degrees. This slope is also called the glide slope. Airports, as a matter of safety, constantly update their local runway barometric pressure for the benefit of the pilot, in proper precise calibration of the altimeter on board the craft. This ensures the most accurate measurement of altitude during the test. So the objective is to fly a Cessna on a fixed altitude ILS intercept course, crossing the signal at either 20 or 90 nautical miles from the runway, and we are taking barometric altitude reading at the intercept point as well as a distance measurement using the ILS system hardware seen here. The approach and measurement can be made several times during a single flight in order to reduce the uncertainty. As we can see here, the pilot will circle the approached runway multiple times. This figure is a representation of the approach pattern and distance for the CYVR airport in Vancouver, Canada. As shown here, choice of airport will theoretically depend on whether the approach path is completely over water. The pilot will file a visual flight rules plan. Those have no mandatory flight levels to maintain for an approach pattern which conveniently uses an airspace which is farther away and at a higher altitude than the avenue which is typically involved when ATC is setting up a standard runway approach routes to the airport. The pattern should be flown at a fixed altitude of 6,360 feet above runway altitude. In flying at a static altitude, we eliminate any delay in the altimeter's reading of altitude, thusly optimizing its accuracy. In cases where the craft's autopilot hardware settings may only, I'm too far here. In cases where the craft's autopilot hardware settings may only permit 100-foot altitude resolution, the duty to fly at the proper altitude will rest on the pilot's ability to manually maintain the proper altitude, because the pilot can still visually see increments in between. As you see here in the circle, this primary flight display's altimeter has a 20 feet resolution, but we can see the 10 feet in between of the 20. The independent variables, meaning the factors we control or change on purpose, are the speed of the craft, the altitude of the craft, and the angle of the beams from the ILS tower. The dependent variables, meaning the outcome we want to measure, are the alignment with the 3-degree angle and the distance to the ILS tower, both shown on the primary flight display. A more detailed description of the entire process will be handed as a method document, which the pilot will use both as a guide to the flight particulars as well as the data collection he will need to fill out. We will do a run-through of that at the end. Just a quick overview of what he needs to fill out. So the prediction is, as shown here, the Earth is flat when flying at an altitude of 6,360 feet above the runway altitude. The craft should intercept the glide slope at 20 nautical miles from the ILS tower. If the Earth is convex, the craft should intercept the glide path at a point substantially closer, approximately 19 nautical miles to the tower. The math to that is the following. In the case of scenario A flat, we apply the sine function, opposite divided by hypotenuse, and solve for the opposite divided by vertical side, the opposite or vertical side. The sine function of that 3-degree angle applied to the distance of 20 nautical miles yields a vertical distance above the runway of 6,360 feet. Hence, a craft which flies an approach of 6,360 feet above the runway altitude should intercept the 3-degree angle at a distance of 20 nautical miles from the ILS tower. Conversely, in the case of scenario B, the globe, the same sine function will yield conversely, the same sine function will yield the first vertical component of that distance of 6,042 feet. Add to that, due to the supposed globe's convexity, the value, which comes from the standard 8 inches per squared miles, which is very accurate for up to 1,000 miles. The result is 318 feet. We obtain this value by applying the cosine of that same 3-degree angle in order to produce the x, or ground distance, component of 115,288 feet, or 21.83 miles. The total of these two components also yields a vertical sum distance of 6,360 feet to the ground from the craft. At this point, the craft should be 19 nautical miles from the ILS tower. Conclusion: this experiment involves a use of a collection of hardware which has been utilized for decades, where lives are at stake in assistance to pilots of all kinds on approach to the runway, a process which makes use of a very necessarily precise light-based guided system. This method is easily replicable and repeatable. Replicable meaning multiple trials in one go, and it is as well repeatable at different locations and by different people. As the time it takes a Cessna to travel 1 nautical mile while flying at around 100 knots is approximately 36 seconds, there exists a rather large margin of separation between those two distance values. This method objectively serves to eliminate virtually all uncertainty in the distance measurement itself. Through sufficient replication by a number of pilots flying at a number of airports, all uncertainty can be completely eliminated. So a video introduction, I show now by a side-by-side animation, which shows what the pilot will see in the PFD when on approach. The glide slope indicator involves a pink diamond, as we saw in the beginning, moving vertically on the gauge. When the diamond is in the center, that is the moment of interception of the 3-degree path. When the diamond is 1 dot above, the craft is intercepting the angle of 2.65 degrees. That is the point where the recordings of each approaches should begin. And we see the approach begin here. And you see the diamond here and there. The altitude is fixed. We let this run through to have this on camera, and I show just a quick summary of the file that the pilots will get. You see the nautical miles are different, and the angle starts at a different time. So I stop this and start the method. Wait for me to pull up to show you the method. It's just 5 points, 5 sentences in there. Method file is here. Screen share. Method. I don't see it. I will screen share the full screen. How do I do this? Full screen. Objections revised. Pull it up. Here. Section. Method is here. Okay. Screen share again. Workplace. Where can I screen share? Here. Full screen share. Full screen. Methods. Method document. Close the assistance here. So we see that we show the pilots that step 1, he chooses an airport. The entire approach must be over water. Step 2, which plan he needs to file. Step 3, check the weather conditions, as we show in the document later. Use the meta source for that, which is a public source. Recorded parameters must include airport temperature, wind speed, wind direction, barometric pressure. We pretty much thought that it's of not so much importance, but we want to make sure the data set is very clear. Step 4, plan the recording. It's about the recording here before takeoff. Make sure that you put the camera stable in front of your PFD screen or help someone with assistance. Make sure that your altimeter is properly calibrated. And when you take off, begin the flight patterns we showed and try to repeat it as much as possible, but of course it's dependent on costs. And perhaps 5 or 6 passes should serve as adequate. To minimize the random error, you can do more. And then land and secure the craft. Use the camera also to make a screenshot of your file which you fill in. and forward all recordings to the author. And yes, so date and time, runway, ILS name. So this the ILS angle from this airport, the altitude, and then in 1 hour steps, 2 hours before the flight, 1 hour before the flight, what is the data, temperature, wind direction, etc., all of that, relative humidity, visibility, and you get this from radio. You can just record that. It's not hard to get. Yes, that's it.
Right. So, so we have two experiments being proposed. One, so this experiment, Kevin, is you need an airplane, right?
Yes.
So not everyone can do, but those you have to somehow go get an airplane, and then you have to so the airplane can make multiple advances towards the tower by circling, and each one of those will give a data point, right? Each time it circles back, right? All right. Okay. So maybe since you just finished, we'll ask, and then we'll go back to the globe earthers. Globe earthers, if you want to ask any questions about this, again, today is merely looking at the formulation of the hypothesis. So Kevin, in your case, you're saying that there's a formulation of the globe earthers. You've actually claimed that you formulated it, and then the flat earthers will have, and then you proposed an experiment. So any of the globe earthers have any questions that you want to raise?
I have some questions about the precision. So, Kevin, you listed off the variables you were going to capture, but I missed what I thought was probably going to be the most critical one, is the margin of error of the slope angle, and the margin of error of the second, the width of the beam, and third, the margin of error of the width of the beam.
The width of the beam is 0 degrees is the one. The second is 6 degrees, and because you have you check the interception point of those two beams, you can see the interception points, and it's in between. You measure the strength of both, and when they are at the same strength, you measure that multiply. It multiplies. I saw it on the. I showed it on the how the beams come out, but there is no because there are multiple lines which are on a line of those interception points. There is nothing out of that line. It cannot be out of that.
Okay, so you didn't answer my question. What is the margin of error of the slope of that beam? You say it's 3 degrees, but it's not exactly 3 degrees. It's 3 degrees plus or minus something. What is the margin of error, and how do we know that margin of error?
The slope angle is 3 degrees on most airports.
Plus or minus something. What is that plus or minus?
It's 1% based on 35 nautical miles, what we tried, but we are in less miles, the margin of error, and there's still this 30 seconds time frame in between, more than 30-second time frame.
Okay, I'm sorry, you still didn't answer my question. What is the published margin of error of that angle of the glide slope?
It depends on the airport. Whatever airport you go, you have a different angle of the glide slope. You maybe don't understand the method.
No.
The method is...
What is the margin of error? Not the angle, the margin of error of the angle. I know that published glide slopes are 3 degrees or varying amounts of degrees, but what's the margin of error? Because at 20 nautical miles away, it's not going to be a pencil thin line. There's going to be a variation because the installation isn't absolutely precise. So we need to know, because at 20 nautical miles, any margin of error is going to be magnified when you're 20 nautical miles away. So what is the margin of error of the different airports you've looked at?
There is a idea that the beams can multiply outside, but it's not in our observation. So I don't see that there's a margin of error beyond 1%, what I mentioned. I don't.
But that's just a guess, right?
No,
you're just guessing 1%.
We tried that. It has to be absolutely precise. You cannot do it different because millions of dollars and lives.
No, hold on a second.
Millions of dollars depend on and lives depend on how the airplane descends. So you cannot.
You're correct, but
it's one degree more or less.
Kevin, if that glide slope is 3.1 degrees, the plane will still land just fine. And if the glide slope is 2.9 degrees, the plane will land just fine. So there isn't a security or not a security. Hold on just a second. I'm not done talking. Okay. There isn't a safety problem if there is a 1/10 of a degree or a 2/10 of a degree margin of error. The plane will still land just fine. And then the second thing is, what is the width of that beam?
It's not about landing. Sorry, it's not about landing. You asked the question, but we are not landing the plane, and it's not about if the plane lands fine. The plane will be at an static altitude, and we have the sine function. It's math, and we are not landing the plane. It will land fine. Okay, 2 meters above or below what it's expected, but we are not landing the plane. We are looking.
Yeah, I didn't claim that.
You said the plane
will just land twice.
So gentlemen, let me just jump in here for the audience here. I just did a very simple, I think this is what, Kevin, you're bringing up. Let's say that center line is that 3-degree line, okay?
It depends on the airport. Most airports have 3 degrees. You can.
Well, let me finish, Kevin. You got to stop when someone.
But you asked the question if it's 3 degrees. It's not always 3 degrees. It can be 2.9 on some airport, but it's
So let me just finish. That's what we understand. Your experiment proposes 3 degrees, and in science, if you've used any instruments for measuring anything, typically the company that provides you that instrument will provide you a plus or minus margin of error if you've done a measurement of any kind of thing, So if that center line is your 3-degree, which is what you're formulating, it could be above or below based on error. It's essentially in a cone, right? It's essentially a region. That is not going to change the nature of the airplane landing safely. However, I think the issue is that can have a significant impact based on the margin of error on the calculation.
Yes, but it's in.
Let me finish.
Okay.
Please. Okay. So the question is, are you aware of what because you're using instruments to measure this? Are you aware what the margin of error is? Because the margin of error varies. That's going to directly, you have to put that into your hypothesis, and that's going to affect the output, which is going to affect whether the Earth is flat or round, and you're essentially introduced something inconclusive a priori. So the issue is, do you know the margin of error? I think that's Mike's question.
Yes, and I answered him twice. He can look it up. 1%, 35 nautical miles away, and this will not affect this experiment. You still would have 30 seconds of change of both predictions. The vertical margin of error was measured at 1% of the vertical height, and you are in the experiment still works very well for both.
But you haven't done the experiment, so you don't know if it's going to work.
There's something similar work happened, like pilots observed their.
Yeah, but time out. Again, this is. In science, you have to do the specific experiment using the specific. If you did something else, that's not this experiment. So we want to talk about this experiment. Has this experiment been done? This exact experiment? Okay. So this is a proposal. That's great. But the issue is, if you work out the math in your equation, this is just some feedback to you. You're going to have to include that margin of error, because that margin of error is going to affect the output.
Yes, it is 1/5 of the difference. And it is,
So
yes.
I have I can show a little more detail maybe for the audience if I can share my screen here. I have it up.
Okay, hold on. Go ahead. You can, I think you can share.
Yeah, I'm sharing it right now.
We don't see it.
You have to select on your tab at the top of the screen. You should see that my presentation is being shared.
Does everyone see it? Oh,
Oh, Dan says he sees it. Okay.
I don't see it for some reason. Is it being broadcast to everyone? Let me see if it's being broadcast.
Yeah, it's on the.
Oh, okay.
Okay. They see it on YouTube. Okay.
Okay, they do. Okay. I'm sorry. Go
Yeah.
ahead.
So here's an approach for an airport in Denver, Colorado. And down at the bottom here, it shows the exact same thing that he's talking about. This is the ILS slope there. And it's got those the gray borders around it above and below. And that's showing the margin of error of the width of the beam, not the margin of error of the glide slope. The glide slope margin of error is not stated in here. And this is the same for every airport. Here's another airport, another airport, another airport. All of these have that gray top and bottom to the glide slope. You see that there? And so that's showing that the glide slope isn't an exact 3 degrees. It's a broader angle. And so here's a diagram that I put together showing that, you've got this in the middle here. This middle slope is showing the exact 3 degrees, but based on an approximation of 0.7 degrees, which is what I get as when I've done some research on what is a potential average value, but we'd need to get the exact value for any particular experiment we did. But you can see here, when the airplane maintaining constant elevation will enter into that cone at 26.1 nautical miles in this example, be in the center of the beam at 20 nautical miles, but there's no way to measure that directly, and then exit that at 16.2 nautical miles. Now, this is my computation for flat Earth, and my computation for the globe here is similar. It's just a slight different one, and it enters in at a different point based on the two models. Now, here's the problem. Here's those two overlaid, and you can see there is a different intercept based on globe, this curving one, which is exaggerated. Don't take that to mean exactly what it is. The horizontal scale is not to scale with the vertical. And then the intercept here for flat Earth is on the top there, and it's a different width, different entry point. But the problem is now, if you don't know the glide slope margin of error of the center, you get this. The center is that, but you actually can't measure when you're at the center very well. You can measure when you enter and measure when you exit that beam. And so what actually happens is this is just looking at the glide slope margin of error, the unknown margin of error. Kevin doesn't know it.
No, it's not the margin of error. You're showing something wrong. The gray section was merely showing the 0.35 degree spread, and the pilot expects this to see on his gauge.
Exactly.
It's not showing,
so
exactly,
it's not
but it's
possible.
not showing error margin.
Yeah, so it's not possible to measure precisely the kind of precision that you want.
23%.
This is just a second. I'm still talking. This is just a visualization of the margin of error of the glide slope. Now, if we add in the unknown width of the beam, because we're just guessing at 0.7, then this in big boundary here gets even larger. So there's no way to differentiate exactly precisely when you enter and when you exit and get to the center of that beam. There's no method to do that.
Why this is 23% error margin you propose is preposterous. You couldn't land any plane with this.
Oh, you can easily land the plane with that. You see down at the bottom left of this where they converge. So no matter what, you'll get to the runway at the right elevation, because the margin of error shrinks as you get closer to the runway. So when you're out 20 nautical miles, it's fine to be to have a really wide beam, no problem for safety at all, and any pilot can land the plane just fine. And then they get guided down, and that gets tighter and tighter as you get close. But you're not proposing to be close. You're proposing to be 20 nautical miles out, where you do not know the margin of error of the angle or the beam width.
But it's not 23% as you proposed.
I didn't. I don't know where you're getting 23%.
You even
I just drew. I just drew random. I didn't put any numbers in here.
You have showed.
Oh, the 0.7. Yeah, the 0.7 is what I got doing research. Yeah, but so if you had any documentation of the width of the beam, then that would be useful. But I've not been able to find any hard documentation because, like I showed, these different airports, they don't document
and exaggerate it like
exactly
crazy.
You can't 100%. You can't approximate, and so you would need to provide, and we don't have that. When we look at the documentation that airports have, there is no documentation that I found of precise beam width. They just have this rough gray area here around it.
Radio frequency, it's in a very low frequency. I can look it up for next time. Never mind. I can look up how the lower the frequency, the stronger it is, and the less it diverts. So I will look up the exact value, but we were in what we looked up was 1%, and your 23% were not in any way.
Kevin, if you're talking about beam divergence, it has less to do with the frequency and more has to do with the antenna design. Also, in your presentation, you said that you were measuring the distance off the ILS system. Is that using the DME system within ILS?
Which system?
How are you measuring the distance, the glide slope distance from the plane to the airport?
Yeah, you have it in your, I showed it on the bottom left. It shows on the primary flight display.
Right. So okay. So because you don't know, that system's called DME. It's part of the ILS system, but it's a separate system entirely from it. Do you know what the margin of error is for the DME system for just random airports as far as the range difference? Okay, so it's 0.2 to 0.5 nautical miles. So when you add just that error margin into a 1 nautical mile difference from your, not even discussing Mike's idea about the beam width, just the measure of the distance, your now margin of error has taken your 1 mile and taken it to possibly half a nautical mile.
It's near zero. Say again your numbers. It is in 20 nautical miles.
You said there's a mile difference between when we enter,
nautical mile,
if it's globe or whatever. There is a half nautical mile margin of error for the DME system that measures the distance.
Show me the reference. I don't believe this. It's the error margin is near zero. If you had half a mile error distance, again.
Because your distance isn't necessary to land, the glide slope is. So your distance could be off by half a nautical mile because where the DME is located and where the transmitting antenna is located on the airport is going to affect what the DME measurement is. And a DME measurement measures the glide slope length, not the overland length.
Fine. Oh, but
so those two systems, so anywhere from 0.2 to 0.5 nautical miles on the high end, you've now taken your margin of error of 1 nautical mile between the globe and the flat Earth and made it half a nautical mile. And that's before you can even address the beam width issues that are expanded upon at 20 nautical miles away from the airport.
With that were exaggerated, we can show this. We will look for the reference, but even if it's half nautical miles, the error there with the distance, the experiment is still valid. You could still
wait, Kevin. Let me just step in here just to explain to the audience. There in science, when you do measurements, it's something called margin of error. Okay, so you take a measurement and you think something's 1 inch, and if the margin of error is half an inch, that means it could be 1.5 or 0.75. You understand that, right?
Yeah, but you cannot come up with some numbers.
Wait,
at
wait,
all.
wait,
So,
wait, wait. No one's coming up with any numbers. Stop.
Yeah, 0.5 miles. Show
No, 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 no,
reference.
no.
It's not.
Stop. Don't interrupt. You kept saying Mike was coming up with 23%. He didn't say that. So take that off the map because I don't want that to be
I
perfect.
showed the math. I showed
No,
the
no,
math
he
for
never
that.
said 23%.
It showed 0.7
No, no,
to
he
3.
said that the beam width, he gave an example. The bottom line is, so let's be clear, because what I've seen happen is people are taking words and then say, he said this. It's not what he said. Okay? So let's stop it right there. That's not science. That's called bullshit. So let's stop it. He didn't say that. What he is bringing up in a very rational way is a concept of margin of error. If you don't know the margin of error, any measurements you make thereafter are subject to being highly dubious, okay? Or you have to incorporate that into your hypothesis, okay?
Yeah.
Okay, so that's all we're saying. So in order to do that, Dan is saying the DME, he knows as an expert in the field, and you should go do it independently, is half a nautical mile.
I haven't shown any reference. It's 20 miles. Don't believe this. 100 miles maybe. 100 miles.
Wait. So where do you have the reference that what he's saying is false?
Because I saw some tests from 10 miles.
No. Wait, stop. In science, there's something called a citation. You have to give a reference. So if you don't have the reference, don't say, he said something.
Yeah, he didn't show reference.
Dave Flat Earth said something.
He didn't show reference. Exactly, he didn't show reference.
Okay, let's define reference. A reference is a reputable source where someone's done the experiment and it's being used. So I think what's outstanding is Dave has proposed here that he has a reference. Okay,
I like to see.
Okay, but you don't have that reference right now. So you can leave it as an unknown. Agreed? It's an unknown variable in your area. And perhaps you and he should connect offline. But in our white paper, we're going to say the margin of error is not known for your measurement.
Yeah, no worries. It's two
So
researchers.
So Kevin, just so you're aware, it's an ICAO standard of 0.25 nautical miles plus 1.25% of the distance being measured. So I gave you the benefit of the doubt by just saying 0.5 at the high end. So if you want to do the actual math of it and everything else, the operational accuracy is a half mile or 3% of the distance, whichever is greater. And that's reliable up to almost 199 nautical miles. And that's from the ICAO.
So Dan, why don't you send that reference over? I think
I'll send it over right now.
That the landing of an airplane using the glide path can happen very safely and securely. That's independent of measuring something in that range that we're talking about concerning the Earth being flat around, okay? One is a measurement issue. The other is a plane landing safely. And I think Mike's point is when you're 26 miles away, you're in some region, but as you get closer, you're always going to be able to land the plane. But in your experiment, you're proposing that you have to measure this at 26 miles, which is a significant distance away. And as you get farther away, if the margin of error, whatever that margin of error is going to significantly affect your delta, or whatever your delta H, the height. Is that the point you made, Mike?
Yeah, the entry point when the plane is coming in at that same elevation, they'll get into that entry point where you'll start where the instrument will say you're in the zone earlier than right at the center of the beam. Because if it was just at that very center, if it was super pencil thin, you'd hit that and then instantly you'd be past it. The pilot needs to know when they enter it, give them time to adjust the plane to decrease elevation so that they can stay within that zone. If it's pencil thin, they'd be past it and they wouldn't know.
Yeah. So I think the outstanding piece in that experiment, or let's put it this way, so you don't take this personally, in your model, the margin of error must be included.
Yes, but no one said something about 26 miles. 20 miles is fine. Even 10 miles would be fine to measure this. And we have data for 10 miles.
Right. So Kevin, whatever you want to do, going back to the scientific method, in that formula, you have to include those variables in your mathematical model. Does that make sense? That's the feedback.
Yes, thanks.
So right now your mathematical model says, can you bring it up again? It says what? something like sine y or something. What is that? Can you bring up your formula?
Oh, yes, wait, the screen share again. Need the PowerPoint. You want the flat or globe? The
It doesn't matter.
comparison,
It doesn't matter. Whatever it is, you're still going to have to include the
right?
margin
Yeah,
of
yeah, wait,
error.
wait.
So you're not going to, you're going to get an answer which is plus or minus
Screen
something.
share, yeah. Yes, yes. You see?
Yeah, so that
20
formula,
nautical miles, not 26. And
right, but that's sine 3 equals y. That formula
Yes,
is not
yes,
correct.
yes.
You have
No,
to
it is.
include a margin of error.
Oh, yeah. But still the formula is correct. But you can include this 1% if you like to. I
No,
would
no,
look
you
for
need
the
to
1%.
It's not what we
Yeah,
like.
no,
You need to
no.
document it.
No, stop. You need to actually include the margin of error based on reality, as close as you can get. Okay? So Dan has given you a reference, and then Mike has brought out something else, but that, I think we're just keeping it very objective here. That equation, the output of that equation, the input is going to be garbage in, the output is going to be garbage out, because you don't have the margin of error.
So if I can share real quickly,
Yes, I stop. But it's garbage is a hard word.
Well, that's called GIGO, G-I-G-O in computer science, garbage in, garbage out. Don't take it personally. But that's what you have. You have a garbage in, garbage out model without the margin of error being included.
so is this up and running right now?
Yep, we can see it.
Okay.
Yeah.
So this is from.
Can you zoom in a little bit? Can you zoom in so we can
Yep.
see the title of the paper? Yeah.
Yeah, so this is from Stanford University and also done with someone from the FAA and the Aviation Management Associates. So this talks about the distance measuring equipment accuracy performed today and future alternative for position navigation training. Specifically, when I was talking about ICOP, it was also Annex 10. I'm still looking for that one. But just right here, if we go down to DME and TACA and its military counterpart are desirable features for providing positioning services. Today's DME is specified to provide position accuracy of around 0.6 nautical miles.
At what distance?
That's the accuracy of the DME as a
the
whole,
DME.
as a system. That's the margin of error for what the value that it reads is coming out at. Because again, the distance isn't what you land with, it's the glide slope. The distance is just a reference.
Can you kindly send that over to Kevin, Dan? So he's got that?
Sure. I mean, do you have the chat open? I can just put the link into it.
Yeah, you can send it over to Dr. Prabhakar and he'll send it.
Okay.
Zoom has this really wacky thing with chat on who can chat to who and how you set it up. It's gotten, I think you have to do a new, yeah.
Okay.
I
Yeah,
saw
I'll shoot
something
it
with
over. I'll
200
shoot it over right
miles.
now. I'll pull my email and I'll send it
Yeah,
over
I need to
to.
pull it up again because I saw something now with
So
200
Kevin,
miles.
Michael, and Dan, is there a consensus that that formula needs to be updated with margin of error? Is that what we're saying? Is that what you guys?
Oh, absolutely. Yeah. And if the margin of error of the slope and the beam width together cannot provide something that's distinct for both globe and flat, then the experiment won't be useful. It's inconclusive, so it'd be a waste of money to do.
Yeah.
It's a
So-
non-issue. Yeah.
Yeah, so I think this is an important thing. To the audience listening, if you get a result out of this and it's in the margin of error between of globe and flat, the number means nothing. Okay.
But the 0.6 miles would be, yeah, we look it up. I stand with this statement, but I saw something with 200 nautical miles. I need to look at the document. Can I come up with my objections or we go on with my?
Well, so I think we've given anything else, Mike and Dan, Prabhakar?
I mean, if they want to do if you want to do a radio experiment, right? Because it sounds like what this falls under is we see too far, and you're using radio as an idea to get rid of some of the optical problems of mirages, of scintillation, and things like that. I can suggest another way of doing this with basically lighthouses, boats, and UHF transmitters and receivers. It's something that's going to keep it under roughly $500, depending on the cost of the boat. And it's something anybody can do as long as there's 3 specific heights that have anywhere from 5 times to 10 times elevation standards. You're just raising the transmitter. You're verifying radar horizon. On a flat Earth, there should not be a radar horizon because there is no geometric horizon. On a globe Earth, there is a radio horizon, and it's directly dependent on the square root of the height of the transmitting antenna or receiving antenna.
So Kevin, is the intent, was this your experiment or someone else's? Because we saw someone else's name on this.
Yes, yes. No, I like to present my.
It said stones this, stones that.
Yes, yes.
And it was all in English. I know you're in meters over in Austria.
No, in the flight aviation is in nautical miles, but it's his experiment. I would like him up here, but he wasn't allowed, and I.
So is this your experiment or someone else's?
No one did it yet. It's just in 10 miles we did the slope.
No, but is this your proposal or someone else's?
It's someone else's.
Oh, okay. Well, this was supposed to be done by the science panel. That's one of the goals here, not someone else's. Anyway, the other thing is, are you into doing the radio, to Dan's question? And what would be the cost of this with an airplane, hiring it? Because we looked at
you can enter Cessna. Yes, yes.
Yeah, so what's the cost of something like this? Because
You
you
can
have
rent
to,
a
every
Cessna
round, because you're going to have to get multiple data points, right? Not just one. Multiple. So assume you need, I don't know what the sampling is. I'm assuming you need like 50, 20.
And actually, I have another quick question, Dr. Shiva, too, is how many airports do you know of, let's say worldwide, that have a minimum 30-mile-an-hour body that's directly off an ILS airport equipped runway? Like, I mean, you brought up one, and I don't even know where that is. I just see a map. Do you know how many there are in the world that we can find that would allow us to do this?
Yeah, I think, so we're looking at cost, viability, and ubiquity.
Okay.
And if you don't know it, Kevin, you don't have to answer it now. It's just
I'm just a question I'm posing, that's all.
Yeah, so if you can just find for the, how many airports are there you can actually do this? What is the cost of doing this? And I'm assuming you're going to have to do at least 50 runs, right? Or 20, there's a certain sampling. How many runs do you think have to do, and how much is this going to cost?
$500 one person, or 300 even, and this one person can already do 10 runs with this thing. And you have hundreds of airports in reach of water. And I like to address this UHF.
So hold on 1 second. It's $500.
But I haven't addressed this other old question.
No, 1 second. I just want to. It's $500 because we have Hanscom Air Force Base right beyond where I live, and as a private pilot, I think it's more than $500. It's about, I think, 300 to 500 per hour flight time just to take up a small plane, and you have to be a member of the flying club to do that. So if you're gonna have to take off, do this, you think this can be done in like a couple of hours or just 1 hour?
Yes, 2 hours. And I have 200 Cessna for 200 euros. You can rent it here. I don't know about the US is always.
Oh, and the pilot also has to
expensive.
be instrument rated too.
Yes.
Right.
Yeah, I know.
So
I know a
think,
pilot myself. Yes, but yeah, some people can do it and file it like that. Yeah.
okay. So I think the outstanding questions, Kevin, are which places can we do it in? How many places for ubiquity? What's the cost? And then the viability question comes down to the error margin. Does that pretty much summarize it?
Yes, but I don't agree with it.
I think it's 2 parts.
But wait. The UHF, there was a UHF proposal from Dan, and this is the worst possible version because you shoot over water horizontally and near the height of water. Everything there yields to most variation in refraction, and we don't want this component.
Right. There is some refraction, but it's also a very
You have
constant model
distortion,
that's used in radio for refraction.
mirage,
But here's the other,
fatamorgana,
can I
everything
finish?
there. We deny this.
Can I finish?
Okay, I couldn't answer a long time.
Because here's the thing, though, it doesn't change the fact that there's a radar horizon at a specific distance. And as you raise the antenna up, that radar horizon gets further and further away. This is your classic, we see too far, which is why I'm proposing it. If it's over water, you can account for specific different atmospherics. You put in abort criteria where if there's precipitation. But here's the thing, it's not, doesn't have mirages, doesn't have scintillation, doesn't have other things that optical has that you may be confusing it with. If you use UHF and the frequency that's in, you do have refraction, but that is a very planned and very obvious thing that anybody with radio experience has noted, and you account for that in your equations, in your mathematical model, and your hypothesis. If you choose not to, because refraction is magical in your book or whatever, then fine, that's in your model. That's not going to play a difference.
Distortion.
But our model
like
will be, and I'll show you exactly what I mean, just real quick, so you can understand what exactly I mean by this. It's very simple. This is Montauk Lighthouse. I also have other
You have
locations.
to share it. Are you
sorry.
sharing? Okay, sorry.
I forgot to click the extra share button.
Yep.
This is Montauk's Lighthouse. This is in New York. This is near me. I know this lighthouse is the only reason why I kind of chose it. I also found 7 or 8 other ones throughout the world, including UK, one not far from actually Mike in Minnesota, some on the West Coast and others on the East Coast. Specifically, what we're asking for is we do one down here at, hold on. Down here at the beach at around 10 feet. We do another transmission up here at the bluff at 60 feet, and you do one at the top of the air at the light tower at 170 feet. Each one will have its own model as far as how far it will go. And somewhere along the line, there is no radar horizon on a flat Earth because there is no geometric horizon. This eliminates all ambiguousness, and you can account for each one, because if, for instance, if you're at the beach level and you lose loss of service at, let's say, 10 nautical miles, and on a flat Earth, if you raise it and you get a signal, that means one thing. If you raise it and get a signal on a globe, that means something else. So then you go out further and see if you lose signal again. At that next distance, let's say it's 15 nautical miles. At 15 nautical miles, what is the cause of something 60 feet up going LOS, loss of signal, unless the signal is tired or attenuated or however you want to say it, to where you're no longer getting services? If you move that one more time up now and you get signal again, there's no explanation, unless you know of one, for a flat Earth of why that happens. There's a very good globe explanation for that. It's called the radar horizon, and it's proof of curvature.
You need multiple repetitions to see the refraction, but the refraction, nobody has access. How many people have access to lighthouse towers first?
But here's the thing, Kevin, I have whole criteria, also different signal, the noise ratios. I also have different error margins and everything else. But here's a bunch of other sites that we can go to. Anybody in these areas can do this one as well. And we're talking about $200 off of Amazon for an antenna and 2 radios.
Well, you agree or not agree that over water, the measurements are more various? Like it's easier to do something higher regarding refraction, distortion.
You're confusing optical with radio. Radio does not have, radio has refraction, but there's no refraction values. You can use the standard model, or as what I actually recommend is you take the measurements to build your refractive index of what it's going to be based off of temperature, barometric pressure, and the relative humidity taken at the boat level and taken at the various levels of the transmitting side at the lighthouse. And from there, you can make a very close approximate model for the refraction index, or what we call the K value, to be able to know how far it's going to change. Already in radio, we already account for this in a standard model, because our radio horizon accounts for 4/3 times the radius of the Earth, because we already know that on a standard atmospheric model, we're going to go 15% further.
But
And
every
this is
rate,
how line of sight is actually, these are the links that are engineered. These are how I engineer my links. And these are specifically how they're implemented in the military and combat zones. So there's nobody hiding anything there because there's lives on the line. And the same reason why telecommunications work in cities like Boston, where Dr.SHIVA is at, because I actually set up links that go from the John Hancock Tower to other locations in Cambridge without using fiber optics, that use radio, that I have to account for precipitation. I have to account for temperature variations, seasons, as well as the frequency it uses, the polarity of the antenna. There's a whole bunch of variables that goes into that, but we control all those variables in this one to where our only variable that's going to actually change anything significantly outside of, say, a 10% margin of error, and I'm just guesstimating what that is because I haven't put any math into this. All my math is in a different document. But if it's a 10% error margin, if the difference between the closest and the furthest is more than 2 times the distance, that more than allocates for the 10% margin that might be there in an error.
you agree though that the distortion and refraction needs to be accounted
What
for?
distortion?
Because
It's RF.
rate of
Can you explain what some of these things, what causes some of these things in your model?
UHF is light, no? Light is affected by
The UHF is not light. It's not optics.
It's not visible light.
It's not visible, right?
but
So
it's
there's no
still a
mirage, there's no
frequency.
scintillation. All you have is refraction.
Yeah, you have invisible light as well, but it's a radio frequency, yeah.
Okay, so what mechanism do you think occurs over water and what effect do you think that would have on a UHF radio signal? Because this is stuff that has been used in the military since, I don't know, for 80 years. And it's been used in the civilian world. This is what I grew up on. If you want to do a radio experiment, I'm making an experiment. Not
Same
from,
with the
I
plane.
still don't know what these, I don't know
And
what
I-
these
and
results going
it's-
to be. I haven't done this experiment,
Yeah.
but this is one that I came up with, and I'm willing to share it and provide it to you guys to have you guys decide whether or not it's something you want to participate in. You guys can make your own methodology from this. I'm just giving you an idea.
Okay. Humidity is one problem, for example. Humidity is not involved in my like that much of if you have water dispersing just in front
just a question.
above the water.
What does humidity do to the propagation of radio waves?
What does humidity?
Yeah, you said humidity is a factor. What does it do?
Yeah, it can. I don't know the full claims, but
Oh, you
I
don't know.
can,
Okay.
yeah.
Then why do you bring it up?
Because you can. It's less there. I saw experiments where they proposed humidity, and I saw formulas there. I can look it up. I don't know the details, but I can look it up. Show you next time.
All right.
The only formulas I have are basically using the refractive index and using known formulas for a globe model, and that is to be the actual way to configure where the radio horizon is to make our predictions. The only way that I can see flat Earth goes, and of course, this is your team. You guys have a week to come up with this model as far as what you think the prediction is. But as far as I can see it, since it doesn't have a geometric horizon, the only thing that limits how far the way a radio will go will be the attenuation of the atmosphere. So that's going to be based on the inverse square law and things like that, to where it's either the signal stops and that's it stops, or it continues on for hundreds of miles and we never get loss of signal. It's a very simple
It's
dichotomy of yes and no.
but you agree that having a distance value is better than having a value of I see something or I don't see it. Then you have some numbers involved in there. And
What
you
I
can
mean by see
compare
and
those
don't
numbers,
see is
no?
I don't mean actual seeing. I mean the radio squelch button sends out an audio tone. When you go far enough out, that squelch cuts off, which means you have no signal. That's a loss of signal.
Yes.
The only way
you
that
have it or you
happens
have
is
it
if
no,
there's
no?
an obstruction. The only obstruction that would be out there would have to be a very, very large wave that you would have actually experienced on the boat before it got between you and wherever the transmitter is. And as
Makes
you
my
move the
point.
transmitter up to 60 feet and 170 feet, that wave that is causing the obstruction, and again, we can hang out at different locations for upwards of 10, 15 minutes. And some of the Bohr criteria would be how big the sea state is. If it's more than 3 feet, no one wants to be out there in the middle of the Atlantic Ocean during this. then
You go
you
very
abort,
much
and you come
into
back and do it
details.
again. But if it's at 170 feet, that's going to have to be a really big wave between you and the boat and the light tower to cause an obstruction. And if you hang out for 10 minutes, that wave is going to go away.
So Dan, just to you're just to understand what you're saying, there's some fundamental problems with their plane issue using ILS. So you're giving them an idea, saying, why don't you use UHF? And in your model, you use a lighthouse or these locations. And if the Earth is curved, it's going to be a 1 or a 0, because you're not
Right.
going to see the signal unless there's a massive wave. But that wave would have to be 100-foot wave if it's from the top of the
Correct.
lighthouse, which is very, very unlikely. So,
Correct.
Kevin, I think you and I think the gentleman who actually came up with the ILS experiment may want to look at this, because Dan's essentially trying to help you guys. Because right now, from the feedback that I'm hearing, you have the margin of error issue that essentially is going to give garbage in, garbage out with your experiment. And this one is this or 1 or 0, because if the Earth is curved, at a certain point, you're just not going to get the signal. If the Earth is flat, you're going to always get the signal. I don't know how far UHF carries, Dan. E equals H nu. I don't know what that comes out to.
Well, I mean, you can go UHF. I mean, we'd have known, I think if I figured out we had 8 watts of power, so doing 8 watts of power, I think we can go outwards of 250 nautical miles in a straight line.
Okay. All right.
I mean, you can use these handheld radios to talk to the ISS.
Okay. So I think
is it 2 beams? But tell me the details. Is it 2 beams compared, or is it 1 beam?
It's 1 beam.
Yeah, see, so 2 beams is more accurate already. So if I have 2 beams,
No,
you have 1
but
beam.
okay. So here's what I'm also telling you to do is you get so you're not just using the radios, you get a directional antenna, which has got a 5-element Yagi antenna. You literally just connect it with a cable to the radio. You point that in the direction of, I mean, I can go through all the steps if you want. I was just leaving this as an idea for you guys to develop. But if you want me to show you what I actually developed, I can show it to you.
Tell me how you measure all the atmospheric conditions all along the path, not only at one point. We have the data from the META report, and
So
if you don't measure it everywhere, it's not scientific.
You can build so do you think that a refractive model, which, again, we're talking about the differences between 1.2 to 1.5, okay, for what we call a K value. Do you think that raising the humidity at one random point in the span, can I finish?
Kevin,
can I finish?
Please don't interrupt. It's hard for people to hear what Dan's saying.
Do you think that at some random point between the boat and the airport, the humidity is going to go from, let's say, 60% to 100%, and then all of a sudden that's going to change that index, that K value, that K factor, that refractive index value so much that it's going to cause the signal to end? Because we can run it at 100% humidity. I'll tell you what the bare minimum is and what the bare maximum is, and what the actual is based on the 2 different readings from the 2 stations involved, which is the boat and the shore station. From that, we can develop a model that says that. And here's the great thing about lighthouses. Since it's a protected waterway, a lot of weather monitoring is done in that area to prevent people from ending up on the rocks. So they have to know these things like sea state, humidity, barometric pressure, what the forecast is. All these different things go into providing advisories to small craft in the area.
All right.
Measuring.
I think
we have a focused beam, but okay.
I think we've beaten the horse here. I think Dan's been quite generous in giving you guys ideas. And I think humidity is frankly has no issue in this, because he's saying it's 1 to 1.5, unless even at 100%, he's saying. So,
I mean, and there are occasions where there's a temperature inversion, there could be ducting and stuff like that. But again, these are forecasted. We can actually look at them. We can actually do all sorts of work right up into the start of the thing to make sure that we're not in that window. You account for these before you start. If that atmospheric condition is there, in which case ducting would show it going too far. And again, not science, because you have an anomalous thing that would basically skew the results. You abort. You come back the next day.
Ducting
not a problem. You come back the next week.
But ducting happens higher. I don't know where you get this ducting from there.
What?
Ducting, tropoducting. You mean tropoducting happens at multiple times higher than our test. So I don't know where you come up with
So-
ducting at your test.
Where is the troposphere at?
Especially because last time you mentioned ducting, I looked it up and it said it's high, it's at 10,000 feet.
Okay, so the troposphere where ducting happens is occurs when there's a temperature inversion. Typically, when you go from low altitude to higher altitude, it gets colder. When the warm altitude is above the colder temperature, that's where you get an inversion. That inversion is what creates ducts. Tropospheric ducting can occur anywhere from sea level to 12 kilometers up in the air. You don't know where it's going to happen unless you know where that temperature inversion layer starts and stops, because that is what creates the top of the duct.
You agree it's a rare?
It's rare, it happens. But again, it's forecast. If there's forecast to be a temperature inversion, because this is stuff planes need to know and everybody else needs to know, especially those in the communications field. If there's going to be a temperature inversion, you don't schedule it for that day.
I agree.
You wait.
We put it in the data set, and it's not something which invalidates any experiment, especially not even yours, because it's happening higher than both of us. So I agree, but
Says the person who hasn't done radio versus the person who has. Okay, sure, we'll take that.
we can do. I did the refraction the falsification test, scaling it down, but we're not here for that. But can we exclude the sun now? Or you're fine with your?
Well, I just want to read some before we move
By
on.
all means.
Look, science is about being specific. There's a lot of nebulous way that you've been frankly speaking, Kevin, and it's a little bit disconcerting. Okay, the bottom line is you don't have a error margin, and that needs to be figured out. You need to come back with a mathematical formulation, and hopefully we'll see that. But it needs to be precise. It can't be hand waving, and it can't be just randomly saying some random stuff. Okay, number one, Dan has proposed to you, if you guys want to use, electromagnetic waves, he's provided you UHF. And that gives you, from frankly, what I'm hearing, a pretty 1 or 0 answer, because it's just based on distance. You've been sort of just dropping all sorts of terms, and frankly, they're all irrelevant.
No,
So
it's better.
No, they're irrelevant.
0 versus 1 is
No,
not
they're
that good.
irrelevant, because when you bring in humidity and you bring it in, it's not going to change the end result in any appreciable way.
No.
And furthermore, let me finish. You also have the opportunity to look at the weather and decide when you're going to do the experiment to reduce those variables. All right? This is like fucking second grade stuff. So please don't.
I included that.
No, let me finish. My point is, as someone who's a working scientist, I don't like people just saying random words to confuse people. And that's what you flat earthers have frankly been doing. And we're trying to get
credentials. We can interject and say fallacies if you are saying those, because it's an appeal to
No.
credentials.
You're just saying, no, stop it.
It's not saying truth.
Stop it. You're not speaking to some social media people who you can bullshit. Okay?
Fallacies are.
You're just randomly saying words that have no meaning.
Look up fallacies. Look up
Okay.
the term fallacy.
Go understand what a model is. Go understand what error margin. That's your homework assignment. If you were in class, you'd be probably as an undergraduate right now. So go understand that. Okay? It's really insulting to everyone out here. So go understand basic stuff. And Dan has provided you, out of his generosity, a way you could do this. If you don't want to do this, stick with your thing. With all its issues, you're going to have to include error margin in it. All right? If you want to do that, go for it. But he's giving you an alternative, which frankly makes it a 1 or a 0. And maybe you guys don't want that.
Of course, we want a good experiment, but I say 1
But
or 0
what your
1 or 0
experiment is.
isn't as good as 2 different distances.
Well, first of all,
where
you didn't
can
do
go
this
closer from one
experiment. A
distance.
guy who was banned from this, and you're lying because you have his name all over the experiment.
didn't lie. I
So
told
you
you
misrepresented. You've misrepresented yourself.
No, I
Okay.
told you as soon as you asked me, who is it? I say it's not my experiment. Where did
No, I had to ask twice. Okay. So you've
You
misrepresented
said,
the presentation
look at the
here.
recording.
This is
Look
not
at the
from
recording.
you. It has his name all over
Because
it.
you do as, yes, I don't deny it. You do association
After I asked you,
fallacies
you
all over.
you didn't say this is not my experiment when you presented this.
It goes still since January. This is since January.
You
is
have an
happening.
individual who's been in the flat earth community confusing everyone, and his experiment has been presented, not yours. That's misrepresentation.
Because you exclude everyone who are the good at math, who are
Good?
the good
Who?
physicians. Yes,
Who?
Stone is good at math.
No,
Ellen is
no,
good
he's-
at math.
Yeah,
I like
right.
Shane
No.
here,
Listen,
and you don't want those people, so I have to take over
Okay,
here.
we can give him a math exam, and I can give him an MIT math exam, and I'll judge how good he is. Okay?
Ellen showed you already kinematics
No, he
and
isn't.
dynamics.
You're not an expert in it.
I'm not, but the
You
others.
didn't
and so
study
I
this.
like
Have some respect for people who put in the fucking time. You're not an expert. Okay? And you misrepresented yourself because you said that was your experiment. That's violating the norms of how we set this up. Okay. That's for the record. Let's go to the issue with the proposal that Mike made. I think we're done with this. Go ahead. Any objections to that?
No.
I think Kevin is
Ryan?
muted.
Kevin?
Yeah. I think Kevin is muted.
you muted.
Yes,
me.
unmute
Okay.
himself.
All right.
Yeah.
So first, you said that if this mathematical model is able to predict.
Now, first of all, why don't you first, because they re-explained what you wanted to do, why don't you, for the record, restate what the experiment that they're saying, the observation, the mathematical model, and be as precise as possible without some hand waving. Go ahead.
I like to include the error margins. I will look up the error margins for the beam divergence and the error margin. The other error, what was the other error margin? I don't remember now because I was already at the
But
sun.
Dan actually gave you the error, 0.6. One is the beam divergence error margin, and the other is the DME, which Dan actually
The
provided.
distance, exactly, the distance.
Yeah.
The 0.6. I saw that in this document there was a 200 nautical
and-
miles,
and-
but
and
I will look it up, yes.
Yeah, I think you should. And then the other things we asked for are, we want to look at the viability, because we have, here around 35 people, and we have about 1,300 people, at least on Twitter. We probably have several thousand people, in spite of all the shadow banning. But those 1,000 people, we want them to be able to do it. Okay. So what would it cost them to do this? And if you can, you said 500, but I think it'd be valuable to know what it would actually cost them to go do an experiment like this. Okay.
Okay.
And that you don't have to, obviously you don't have to give that right now, but it would be good between now and the next meeting to have that. Maybe we'll do another pre-meeting because Dr. Prabhakar is actually going to do a draft document, a white paper, which we'll publish. Okay.
Cool.
Let's move on to the flat earthers now questioning the globe earthers on their proposed experiment of using the altitude and the azimuth of the sun, which is observable pretty much to every being on this planet, and a simple formulation that flat earth would have to come up with. And based on, by the way, to flat earthers listening, you can do whatever assumption you want, whether you want to say there's a dome, whether the dome's spinning or not. You just have to state the assumptions and you have to derive your model. Same things for the globe earthers. You're going to have to derive your assumptions and you'll come up with your model. So relative to that, Kevin and Ryan, and unfortunately Bobby's not here, what are your questions to the globe earthers?
Yeah, you think that if this mathematical model is able to predict the observation of the sun, then you have evidence flat or round. And I
Yes,
say,
so you would have to come up with your model, you take in all your assumptions, and then you have to develop your mathematical equation. Does that make sense? So you're going to put latitude in whatever you want to do, full freedom.
The methodology makes sense in a different. Oh, sorry, you cut off. Yeah, you cut off. Yeah,
yeah, but I'm saying to you, and we're giving you between now and the next week to come up with whatever assumptions and formula. Same thing, the globe earthers. These could be very complicated formulas, but the input to it should be latitude and longitude, the time,
projection,
whatever you want to include. Whatever you want to include. It's up to you.
I have a problem now with the grid system. You are already using a globe grid system.
No. Wait. Time out. The globe people come up with their assumption. You come up with your assumption. Don't be. This is what you guys keep doing. You keep talking about the globe. Yeah. Let the globe people come up with their model. Don't go attacking the globe. What do you want to do as flat Earth? So
I'm not here to critique the sun, or don't I?
No, you have to, the flat earthers have to come up with their model assuming flat Earth. So this is what's going to really put where the rubber meets the road. You can't go pointing at the globe Earth people. What is your model of a flat Earth? And come up with your formula. By the way, I've actually done it.
We have math as well, but now we have spent half an hour to object my
but do you understand that you have to just to be clear, just like for your airplane example, the globe earthers have to come up with their formula and flat earthers will come up with theirs. For the sun model, you have to come up with your flat Earth model and the globe earthers have to come up with their model.
You want to do an observation, and I did the whole experiment. There's no experimentation suggested already. This is my first critique.
What's your problem? The experiment is I'm looking at the sun.
And what are the dependent and independent
variables? Wait, Kevin, I really have to wonder whether you've even been listening for the last 2 hours.
I've listened to the pre-recordings as well.
Okay, I'm looking out my window. Let's keep it really fucking simple. The sun is going to be at a certain height, and don't interrupt me, and a certain azimuth. Do you understand that? Do you get that concept? That's the observation.
And there's no prediction coming. It's a post-diction.
We finish. You're going to look at it. Your model is going to predict where the sun's going to be. And if that model matches the observation, then you're right. What are you missing here? Did you not understand F equals MA?
F equals MA is
did you not understand what we spoke about in the beginning?
Yes. It's something completely else. But we have no prediction here. The sun appears in this at your window, coming back to the next time. You have no connection to the ground.
What are you talking about?
That with the
what are you missing here? Should I do it as a kindergarten drawing for you?
Start with a lat-long system, please.
Start with what?
The lat-long system you suggest to insert as a location value.
Okay, I'm not going to talk to you because you seem either not understanding something purposely.
I'm understanding very well that the lat-long system is part of the spherical model already. That's
their model. So you're going to have to come up with your own model. Why are you talking to globe people?
So if you need to simplify, you can say, for a person standing in this city on this street corner or on this beach on this spot, you don't need to use lat-long. Just use a position and create your own coordinate system.
Perfect.
You can create any coordinate system you want. Spherical, polar, Euclidean, non-Euclidean, linear, non-linear. It's up to you. That's called mathematics. So you're going to use your coordinate system to define, let's say, position of the observer and the position of the sun. Your mathematical model will take the position of the observer and time and output a position of the sun. Everyone clear on that? It's really simple. It's trivial. Okay, that's your formula. Flat Earth will have its formula, which is called a hypothesis. Round Earth will have that. To verify this, the experiment is pretty simple. You go out to a point at that position and you look out and you see where the sun is. That's the experiment. The cost of this, I would say, would be what? Your hourly time to do this? So if I'm billing at $500 an hour and it takes me 15 minutes to do this, okay, it's $125. That's the cost. And then you write down the number. In fact, you could go now and you could find many, many locations that are on the internet, which are just pointing cameras. So we could do this live. So the question is, what are the opposition to this experiment?
All right. The tool is the phone is user error is high, much higher than at our experiment. But I first need to start with experiment or not, which I tried to say a couple of times, because we don't have this surface of the Earth value, and we want to determine the surface of the Earth. And then we have two models of the sky, but we don't have the connection to the ground. And we observe the sun in the sky, which is nothing like an experiment for the surface of the Earth. Those two things are very different. And I don't know why I have to remind you on that simple truth. I tried to do it in the pre-show, but
what are you talking about? What simple truth? Are you telling me you don't know where the sun is when you're looking out your window?
No.
It's to the left, it's to the right, it's above and below. What are you talking about?
But what is your connection?
You're talking a bunch of nonsense right now. What are you talking about?
I'm not.
I don't know what you're talking about, Kevin.
You
look
haven't
out your
shown any
window, the
math.
sun is at a certain location. Everyone could come to my house and we could all look out the window if you want to keep it constant, and flat Earth predicts where the sun's going to be, and round Earth predicts where the sun's going to be. It's that simple. Why are you making it so confusing?
Because it's a post-diction and not a prediction, because the sun has appeared in that position.
No, you predict. No,
all the time.
no. You predict it, and then you look at where it is. So your mathematical formula will predict it. Do you want me to show this to you in sort of more kindergarten terms?
Gaslighting.
Will that help you?
No,
Okay.
we've gone.
Here's my
We've
window.
gone over it
See this?
in the pre-show. I perfectly understand what you would
No, I
like
don't
to
think so,
observe.
because
Yes.
you're asking really dumb
Perfectly
questions.
understand.
Here's my window.
No,
This is my window, okay? And the sun is going to be somewhere on this window, right? But before you even do that, you run through your formula, as Dr. Prabhakar shared in the pre-show. You're going to have your formula. Let's do it again. So you're going to have, let's say flat Earth has its formula. Flat Earth is going to take position and time. And you're going to output X1, Y1. That's a prediction. Get it? That make sense? You get that?
I'm critiquing prediction, but you can call it like this, yeah. But look up the term. When I had to write down.
Wait. Listen.
I had to write down some things. I like you to write down post-diction. Look it up what it is.
I don't give a fuck what you're talking about. This is what a prediction is. You're just making up shit. This is a fucking prediction. You put in a position and time, and you're going to get an X1, Y1. Okay? This is, I think you hopefully attended like high school. You learned this set.
You didn't even heard my intro.
All right. Well, this is really not for you, because we want to really raise the standards of everyone else who's being polluted. Okay? Because you seem to want to pollute people. Okay?
I like an experiment.
I think you're just saying words. Do you understand this? This is a formula which will predict globe earthers are going to have their formulation. They have 1 week to come up with this formula. You're going to have to come up with yours. Are you capable of doing that?
We can try something, yes.
Something. No, you guys should be able to know math. We gave you guys a week. The original thing was you would do it live. Okay?
Yeah, invite Alan, invite Space Audits math genius. Then you can do it live.
What you want.
Okay.
You can go. You have all week to go and do it, and you can come present. You can go talk to Einstein. You can go talk to anyone you want. Okay. So let's stop the bullshitting, because this is what you guys have been doing to fuck with people. This is
No.
what you're going to have to do.
So
Go get the predictive formula.
explain how,
No, do you understand this? First of all, don't even say anything. Do you understand this? We talked about it. You said you did. You have to
but I
come up with
raised my
formula.
objections. I said I will
No.
comply.
Do you know how to do this? Don't talk about your fucking objections. Do you know how to do this? I'm looking at my window. There's going to be, this is the x-axis. This is the y-axis. This is the x-axis, okay? This is my window. And we can literally measure it on my window. That's x, and this is going to be y. I can't believe that you guys have been getting away with no accountability. This is x. You get it? This is going to be the x location.
I had the X and Y in my proposal. Yes.
This is x and y. So you're going to have an x location. I'm going to use x1 just because that's what's in the formula. Okay? For convenience. So you're going to have to, flat earthers, if you're listening, come up with a formula for x1, y1. Okay? That's x. Does that make sense? So a location on here, and this is going to be y up here. In fact, this should actually be just x. X, and this is y. A point on here is going to be x1, y1. So let's draw a point right here. That point right there, we can put the sun in to make it yellow. This is what I actually observe. And this point is going to be x1, y1. Okay?
Mm-hmm.
So this is your predictive formula, the hypothesis. This is what you observe. And if x1, y1 equals what you predict for F, you're right. If x1, y1 equals what Globe predicts, they're right. So the first step is you're going to have to go build this formula, which you agreed to do, and we gave people a week. So that's all that needs to be done. And you can also, we're south-facing, and we can look out my building, and we can track the sun. Or anyone can do it anywhere. What's beautiful about this is you can do it anywhere on the planet. Okay? And what I like about this experiment, it's going to reveal the scientific method. It's so simple, no one can weasel their way out of it, slime their way out of it. They have to do the math, and they have to do the observation, and we can literally do this in Excel in about 20 minutes, and it's over. It's over. Dave Weiss is fucking over. And that's why he's not here. By the way, Dave Weiss Flat Earth was invited here, and he called me a demon. All right? So
and now you throw everyone out who's in somehow related to him.
Oh yeah, all these wonderful people who know how to do math, Kevin. Yeah. Amazing intellectuals.
You don't know.
I do know. I do know. I've been doing math my whole life, and you haven't. So start
Yes.
respecting people who do the work, and you haven't done the work. So we're giving you an opportunity to do the work. Giving everyone the opportunity. So
No
anyone
gaslighting.
listening out there, develop this formula, and it'll actually, if you can do it yourself, but it does take time, and it does take effort, and it does take professionalism, and it does take skill. You can't just bullshit. Days of bullshitting are over. So that's what needs to be done. So it's 1:30. I think there's really no objection in this process. It's so ubiquitous. So what we expect, and we can do a follow-up meeting, is each team needs to build similarly for your airplane. The Globe people are going to develop their F, right? Their G, Mike. You're going to have to build your G with the error margins. And Kevin, you're going to have to build your F function. Two functions need to come out with the errors. And same here. We just did. And let's settle this question once and for all. and educate people of the scientific method and how it should be done. All right, and let's stop and let's help people really understand evidence is reproducible predictions. Because for everything you see on my window, if whichever formula is right, it's going to predict it perfectly. And flat earthers may have multiple formulas. If you want to do multiple, go for it. One may say the globe is turning or whatever. Dome is turning, the dome is still, the sun is here, whatever you want to use. You guys have full freedom. Same with the globe earth people. Some people have said the globe is slightly elliptical, right? A little bit flattened at the edges. Other people said it's perfect. Whatever you guys want to use. So what's going to be really exciting is next week, present your assumptions, how you came up with this formula. Same here, present your assumptions, how you came up with this. So we're leaving today with the flat earthers with their airplane thing and the round earthers with their sun thing.
I found what I wrote down. Sky doesn't offer direct measurable information direct to the ground because it's a phenomenon which is independent from the concrete geometry of the surface. Direct observation of the ground is necessary to determine its shape.
It doesn't, what you just said is nonsense. It's bullshit. You're just saying random words. Don't bullshit me, okay? You're just saying random words, follow the scientific methods, come up with your formula. If you believe that, use those assumptions and come up with your formula. It's called a hypothesis. Your words, randomly pulling words that you're getting chatted to at this point is useless, okay? Let's stop the bullshit.
So how many meetings you want to do, like more?
We're going to do the next, well, the next meeting, you should have your formula. So let's go back to where we started, and we can close this meeting. We started this meeting saying, here is a scientific method, okay? Observation, your observation is going to be the one case the sun, one case the airplane. And then to everyone, you're going to come up with a model, and then you're going to do your experiment, and you're going to gather data, and you're going to compare if your data matches the observational, and then if it's right, you're right. If it's wrong, you're fucking wrong. And it doesn't matter how good you look, what your accent is, whether you're white, whether you're black, you're just fucking wrong, or you're right.
Credentials.
What's that? You have a problem with credentials that I worked hard and you
I'm
didn't?
saying it's also not valid here. If you have
No, but there are people who put in the time and work, like a plumber or electrician. So don't deny people's work.
No,
okay?
I don't like you
don't
to
diminish.
to
No, don't diminish
credentials when I don't.
If you didn't do the math, you didn't do the math, okay? So don't diminish people with skills, and that's what you're doing.
I did the math. I looked my stuff up, yeah.
You didn't include error margins.
But I did a lot of math. I don't see a lot of math this week from you, but I can wait for next week.
Wait a minute. We said in our pre-meeting, we gave you guys, Mike said he was ready with the math. You needed more time, so we gave you a week. Your math is like childhood math. Okay, that's a children's math.
Where's your math? From the sun.
Wait a minute. We said that was going to come next week because you needed more time.
For the other experiment to...
Wait a minute.
For the other experiment.
No, wait.
No, then we misunderstood.
I
thought you had
you're just bullshitting.
Math?
Why don't you go hang out with Dave now? Okay?
No, I'm
not what this
fine.
is.
No,
yeah, you are. You're bullshitting. No. Don't fuck with me.
No, I don't.
Don't fuck around with me, okay?
I don't.
And let's just, this is one of the great physicists of our time. Let's end with what Richard Feynman actually said, okay? I don't know if it's on here.
No sound.
Huh?
Maybe no, I didn't hear sound.
Yeah, no sound is coming through.
Hold on.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we so don't laugh, that's really true. Then we compute the consequences of the guess. to see what, if this is right, if this law that we guess is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
That's pretty much it. Okay. So enough of the bullshitting. Come up with your hypothesis, compare the data, and if it matches, you're right. And if it doesn't match, you're fucking wrong. End of story. That's why we decided to do this today, because there's far too much people bullshitting and making statements without ever having to back anything up, and they're monetizing it. And those days are over as what the summit's on. So we have 1 week to the teams to go away. The globe people must come up with 2 formulations, one for the sun's location and I guess the airplane's height. Is that right? The distance? Whatever, I think
distance margin error, yeah. Error of margin error.
Intercept.
It's the intercept. And the flat earth people need to do the same thing. 2 formulas that can be executed. You can use a spreadsheet, if you want to use MATLAB, whatever you want to use. If you want to use a computer program, etc. And that should give numbers for a particular location. We should just be able to compare both things. So we should literally be able to have 2 spreadsheets. One is a globe Earth prediction, the flat Earth prediction for the sun, and have a bunch of sun locations and just compare. And then do that for the airplane example that Kevin wanted to do. And you have to look at if the results are within that, where they appear within the margin of error, right? If they're so nebulous, the experiment was a bad experiment. That's what it proves. So that's it. I think hopefully to the audience out here, people know what the scientific method is. Hopefully people want answers. They don't want to live in a state of confusion. And let me make this last point. I think those in power are manufacturing confusion. Noam Chomsky wrote a book called Manufacturing Consent. I'm writing a book called Manufacturing Confusion. And they manufacture confusion because when people are all fucking confused, you can control people. And when you apply science and you can get to definitive reasons, you can't control people. So you really have to start thinking, who is manufacturing confusion to control people and does not want to get down to actual answers? Who is using words and language, which is this random shit, vomiting shit, and who is using precise language and holding people accountable? That's the world we live in right now. Every Tom, Dick, and Harry can get a camera and a microphone and say whatever the fuck they want. And this is creating confusion, and people are profiting from it, and they don't have to be accountable. What's wonderful about the scientific method is it makes people accountable.
I never monetized anything. Look, NASA budget.
Why are you? I'm not even talking about you. Why are you taking this personally?
No, because NASA budget is very high as well. You don't only look on one side.
I just attacked everyone at MIT with the scientific method, and because you flat earthers didn't want MIT people, we kicked off all the MIT people. Okay.
I thought this is with MIT people here. That's why
no,
I
because
was interested.
Flat earthers were attacking me. This is an MIT conspiracy. So we threw off the 2 MIT people who wanted to come because you guys are finding any loophole. You said, oh, the summit is not going to be lively streamed. It was live streamed. I have evidence here of your guy Stone, who's the one who gave you your experiment, attacking me. All right. So let's stop the bullshit. And November 15th is going to be a day of reckoning. What is true and what isn't. And let's not go threaten people also if they tell the truth. Okay? There's been a couple of flat earthers which have threatened people on the round earth side with death and murdering them.
The other way around.
Not you. I'm not talking about you. If you're going to defend them.
I said that it happens.
Okay. So we don't want any of that. All right? And the same thing has occurred in the scientific world. People who say opposing things to mainstream establishment get vilified. So we want to apply science here. All right, let's give everyone closing statements, each person on each side, and we'll close out. Dr. Prabhakar, we'll start it with you. Any closing statements? Can you guys hear me or no?
I can hear you.
Dr. Prabhakar? Prabhakar, you can go. Okay. Maybe you can't hear. Let's go to Dan. Any closing statements?
No, I'd just like to say thank you for allowing me to participate on this. So I think it's educational. Kind of goes along with what I'm trying to do as far as, through my daughter, trying to teach her things like this, and she gets to see something applicable. She gets to see the design of an experiment and what the pitfalls are when you start dealing with vagueness and stuff like that. So I appreciate this and being able to use this as a tool for my own parenting and also for the public at large. So like I said, I mean, the experiment I designed is not a gotcha. It's not designed as anything other than just a simple dichotomy of 1 or 0. It's a binary decision. I'm happy to forward it. I'm happy to send it to Kevin or anybody else if they like it. If they don't, that's fine too. I'm okay with that. I'll probably do it on my own, maybe with Mike.
Well, Dan,
we'll go do that
you're allowed if you want to propose that. If you want, also, it's up to you.
No, I
Good.
like Mike's sun model, because the reason why is because we have never seen a model for the sun for flat Earth or, well, for anything. So to be perfectly honest, that would solve a lot of questions, and it'd solve a lot of questions that we have regarding their model. But if we don't end up doing mine, that's fine. It's still, I think it's well thought out. I'm going to do it for my channel. Maybe I'll do it with Mike, and because there's one in not far from in Minnesota that we can go to, and maybe we'll do some collaboration or something like that. So as far as I'm concerned, if they want to do it, it's great. It's there. I'm willing to give it to them. If not, that's fine too. I'm okay with that.
Okay. Ryan, do you have any closing words? Ryan Shea?
Closing words. It's just a lot of. Can you guys hear me?
Yeah, I think the next step is, Ryan, each team's got to go out and do their formulation.
Yeah, do the work, right? Just go do the work. And I agree with you. Cut the bullshit out. So stop bullshitting. All this other kind of nonsense of attacking. I mean, it's dumb. It just to me nullifies any type of evidence, which an observation of what we're talking about. So just facts. That's it. And we need to go do the work. So we'll go do the work. Go get it figured out. That's it.
All right, Ryan, thank you. See, Bobby joined. I don't think he did. Let's go to Kevin. Kevin, any final words? And then we'll finish up with Mike.
Yes, I'm not so glad with the development of the participants, because I would like to have some people involved which I think are good enough on my side. I will present their model or their ideas then on my own, and I think I can be reasonable and not bullshit. I also don't like that so many engineers dropped, or because I spent a lot of time myself trying some experiments. The whole winter I did one refraction test. The whole summer last year I did the fishing line test. It's a lot of work to do proper testing. So if any engineer sees it and like to participate, also as well as pilots, you can get back to Shiva or to my YouTube channel. Is written down as my name is, that we can connect each other for next week. And yeah, so and the rest will develop with the next week then.
Great. Mike, thank you, Kevin.
I'm optimistic that we can come to an agreement. Thanks.
Great. Thank you.
Yeah, thanks. I'm glad to be able to have this opportunity. I'm excited to put together the model for both of these experiments. I think that hopefully the call can go out to other flat earthers to help out Kevin. Contact him with your model. For 150 years, flat earthers have been making claims about the particular model that they have right now. And they have included the position of the sun. There's dozens of books that flat earthers have written in the last 150 years to refer to. You should be able to go to that literature for sure, but definitely love to see that put together and hold all of our feet to the fire to test our models. And if they're shown to be wrong, then we're wrong.
Yeah, I just want to let everyone know that one of the things we need to understand is with our senses that we have and now with instruments, we look out into the world and we make an observation, we have a hypothesis of what we're seeing. You know, the original Bohr model of the atom was an electron circling the nucleus, right? It was like the solar system. And it offered certain predictions, valence electrons and so on, but it didn't offer everything. So then that model, which was like, you could draw this concept of an electron moving around. We don't know what an atom really looks like, right? Per se. And then that was updated, the electrons were updated to be a statistical cloud, okay? And then that offered more reproducible predictions. So please understand in science, we're looking at observations. We, in our human mind, which is limited, by the way, are coming up with a concept of what the world looks like. And then that's why you do the testing to come up the evidence of reproducible predictions. Richard Feynman said there were certain phenomenon that science has come across that don't make any sense to the human mind, but are actually true, okay? Just because we can't comprehend why something can be true, but if the math shows it's true, it's true. So what we're looking at is a model, and we're trying to understand those models, but you can't have a human-centric model of the universe. Ultimately, that's what's the power of the scientific method, because it reveals things that may be counterintuitive. And some of those things are why Feynman won the Nobel Prize in quantum electrodynamics, because certain things, if you watch some of his lectures, he says, you know, this stuff works, but I don't know why it works, but it's true. And there are phenomena like that. So nature is extremely, extremely non-intuitive. And that's why we use the scientific method. It doesn't matter what the fuck you think or how you try to talk or how well you talk. If the results match the hypothesis, it's the fact. So be very, very careful of people who just talk and talk and talk, but don't have any math, any framework of science to back up what they're saying, and hold them to the fire, like Ryan said, and Michael, and I think all of you guys are agreeing to this. We need to hold people to their fire, okay? Otherwise, it ends up with confusion. Confusion leads to control of all of us. All right, thank you everyone for your participation. I think we did it pretty well, but next week, 2 models from each group and honing out of the methodology. And then our goal is we're going to put that into a white paper, and then the results, if we get whatever they are, I think the agreement we have as gentlemen and gentlewomen are wherever the axe falls, you're going to have to be big enough to carry with it, you know? You're going to have to be man enough to accept the results if they match it or not. And that's the agreement. All right, everyone. Thank you. Be well. Best to all you and your families. Thank you. Be the light.
We have allowed our country to be taken over from within, and the end goal is you will have a homogenized world where we will become slaves, because there is a condition among the elites that really thinks they're better than you, deep down inside them, that you don't deserve the freedoms you have. They don't. This reality is what people need to wake up to, and we need to all unite working people. There's only one movement that can do that. And that is the movement that we started creating here in Massachusetts, the movement for truth, freedom, and health. Look, I've been a student of politics since I was a 4-year-old kid, studying revolutionary movements, left wing, right wing. There's a physics, there's a nuclear science to destroying the establishment. To build a bridge, you need to understand Newton's equation. You need to understand the laws of gravity. You need to understand Poisson's ratio. There is a way to build a revolution. And that's why I put this together. My goal is to train an army of truth, freedom, and health leaders. We don't need followers like social media. We need leaders, but they need training because the educational system does not teach them history, nothing. So in 3 hours, that's what I've started doing. That's the solution. We got to train people. First, with understanding what a system is, the dynamics of all systems that affect nature. The second is understanding the interconnection between truth, freedom, and health. Freedom is the ability to move freely, communicate freely, talk freely. Without freedom, you cannot convert ideas, hypothesis into truth, which is science. And without freedom, you can't really get to truth. And without truth, you make up fake problems and fake solutions, which means you destroy our health. And without health, which is the infrastructure of us and our body, you can't fight for freedom. Truth, freedom, health. Third concept is it has to be bottoms up. Working people, people who work uniting. And what the right wing has done is whenever you say working people unite, that must be communist. Meanwhile, they've let the Democrats run unions, which suppress workers. Completely corrupt. But when you look at the arc of American history, it's been when working people came up. We need to go local. Every solution I'm coming up with as a part of this movement, we're giving the science, which is the truth, and then we tell people what they can do on the ground. Like with election fraud, you don't need to wait for some lawyer. Our goal is to train people to go local, to go local, to go local, fight locally. Forget lawyers, forget politicians, forget celebrities. You got to learn politics, and there is a science to it. They lock us down, we should be ready to shut them down. And the fourth part of this principle is the not so obvious establishment. So when you look at a system, there's always something that disturbs you from getting to your goal. Well, the biggest disturbance is the not so obvious establishment, which are those people who claim they're for you, on the left and the right. The Al Sharptons who tell black people I'm for you. The Tucker Carlsons. Do you think any true anti-establishment person will ever be on Fox or CNN? I don't think so. They both mislead working people back into the establishment. Without this solid understanding of political physics and theory, you're screwed. You're going to follow on the left wing, Bernie Sanders. Oh, he said something. Or Robert Kennedy. Scumbags. Or you're going to follow some right-wing talk show host. They're not going to lead us to liberation. It's us. We're building a bottoms-up movement, and that political physics, it's a nuclear science of change. Bottoms up. We have to organize to understand that there is people who talk a good game and then look at what they actually do, left and right. I'm sorry, Sean Hannity may say some good things, but I don't see the urgency in his voice to get something done, and it can only come when you weaponize yourself with the right knowledge. You need to be able to identify a rat. You know, Christ didn't go after the Romans, right? It was the Pharisees and the Sadducees who screwed him up. His own quote-unquote people. And that's where we're at. So these four concepts I've built into a curriculum where people can go to truthfreedomhealth.com, and it's an educational program. We need to train people in political theory. You need to have physics, and I've created that curriculum. People need to get educated. We need to get educated fast. And within a half an hour, I can teach people. 2 years of MIT control systems, I teach people those concepts. Then I apply it, anyone can understand it. And then you say, oh, I got to build a bottoms-up movement. They have to get politically astute, and then they have to go locally and act, not sit there on social media. They have to act locally, defy locally, do civil obedience locally, but with knowledge on how to build a movement. Now, the Senate campaign's expanded to the movement for truth, freedom, and health, and they can find it on truthfreedomhealth.com, so people can sign in, they can get access to a bunch of videos. If they want to take a course and become a truth, freedom, health leader, I offer a full scholarship there, but we want people to make a commitment that they'll study, that they'll get certified, that they'll go do activities on the ground. So go to truthfreedomhealth.com.